In this section, we are going to be treating the dplyr package. The dplyr package is an R package designed for data manipulation. So throughout this section, we are going to be performing data manipulation operations. I'm going to be showing you ways in which you can manipulate your data. So first of all, we need to install the dplyr package. If you don't have it installed on your PC, use the install packages function, dplyr. So those of you that don't have it, you can use this code to install it. Then after installing it, then you now load it. Library dplyr. In this lecture, I'm going to be showing you the data we're going to be using throughout this section to show you how you can perform data manipulation on any data sets in R using the dplyr package. So the data we're going to be using is the NYC Flight 13 data, which contains the details of all the flights that departed New York in the year 2013. So this data was stored as a relational database. A package was created so that we can be able to use this data for practice purposes. So if you don't have it, you install it using the install.packages function. Packages function NYC Flights 13. And after installing it, then you now load it. Library NYC Flights 13. So that is the package NYC Flights 13. So this database contains 5 data sets in it. So it was stored as a relational database. A relational database is made up of 2 or more tables that are related to each other. So the first data where I'm going to be showing you is the flights data. So the flights data, let's check the documentation for the flights data. So this is the flights data. You can see that it contains the columns year, month, day. This is the main data that we're going to be analyzing. So any other data is related to the flights data. It has information which is related to the flight data, but this is the main data we're going to be analyzing. So let us have a glimpse of the flights data. So I'm going to type in view flights. So you can see that this is the flights data. It opens in a new tab for us. So we have the column year, which is 2013, we already know, and we have months. So this is the months, and we have day. So each column is for a particular flight that departed New York. So we have departure time, and this time is stored as hours, minutes. So when you see 517, then that means 5 is the hours, then 17 is the minute. So we have 5:17. That was the time. 5:17. This is in the morning. 5:17 is the time it departed. So this is how it is stored. So if you see something like 15:17, then that is a 24-hour format. If you see something like 22:17, that means the flight departed around 10 p.m. in the night. That is a 24 hours format. So this is the departure time for the flight. Then we have the scheduled departure time. This is the time that the flight was scheduled to depart, but this is the time that the flight now departed. Then we have departure delay. If you can see, when you subtract this from this, you have the departure delay, which is 2 minutes. We have 5:15, the scheduled departure time, and we have the departure time. So this is the arrival time, and this is the scheduled arrival time. So in this situation now, the arrival time was 8:30, while the scheduled arrival time was 8:19. So which means there was a delay of 11 minutes. If you also notice in the departure delay, there are those with negative numbers. So meaning that they departed early. They departed before the scheduled departure time. Or also they arrived before the scheduled arrival time. So when you see a negative value, it means that the plane actually arrived at the location before the scheduled arrival time. Then we also have the carrier. I'm going to talk about the carrier later. We have the carrier. We also have the flights. This is the carrier code. Then we have the flight number. We also have the tail number of the plane, just like plate number of a car. Then we have the origin. That is where the plane is departing from. Then we have the destination, where the plane is going to arrive at. So next we have the air time. The air time is the amount of minutes they spent on the air. Then the distance is the distance they traveled. Then we have hour and minutes, which is for the scheduled departure time. The scheduled hour and also the scheduled minute that is supposed to depart, then also the timer. So this is almost similar. This hour minute is just similar to this scheduled departure time that you are looking at in this place. Then we also have the last column, which is time hour. So this is all about the flight data set. So this flight data set you are seeing was now as most of these columns have relationship with other tables. So that is why it is called a relational database. So for those of you that are familiar with SQL, then you are going to know that in a relational database, sometimes there are keys in a particular column which is related to another column. Like for example, now this tail number is a unique column. So each particular plane has its tail number. So now you can now use to get information about that plane in another table. Also, we have the flights. You can use it to get flight ID. You can use it to get information about the flight also from another table. So most of the time we call this the primary key. So now let's look at the airlines table. This is the flights table. Let's look at the airlines table. So this is the airlines table. So you can see that there was a code in the flights table, carrier. This is the code, carrier, as you are seeing it. So this carrier can use to get the name of this particular carrier from the airlines table. So you can see for 9 it is Endeavor Air Inc. Then for AA, American Airlines. For AS, Alaska Airlines. For B6, JetBlue Airways. DL, Delta Airlines Incorporated. So if I want to find out, okay, what is the name of a particular carrier, then I can use this key, this carrier, which is it is called the primary key. I can use to get information from the airlines table. Then the next table we are going to be talking about also, we have airport table, which contains detail about the airports. Sorry, it's supposed to be airports. Now, if you look at this particular column, origin and destination, you will see some codes. For now, we don't know which code is this. We know that this is the origin airport and this is destination airport, EWR and IAH. If I now want to find out more information about this, I want to know this particular airport, then I now go to the airports table. Once I go to the airports table, I look up the code, and I can now know, okay, this is what I'm actually looking for. I'm looking for this particular airport. So this is the code for the airport, which you are seeing in this place as origin and destination. So it is called FFA column. So this is the airport's code. You can see Lansdowne Airport, Moulton Field Municipal Airport. We also have the latitude and longitude. This is the location of the airport. We have the altitude. We also have other column called TZ, DST, T-zone. So these are the other columns in this particular table, airports. We have also the planes. We have the planes table. So you are looking at the planes table. I showed you earlier on in the flights table that each particular plane has a tail number, just like the plate number of a car. So with this tail number, you can now get details from the planes, from the plane data, from the plane table, such as the year the plane was manufactured, the type of the plane, the manufacturer of the plane, the model of the plane, the number of engines on the plane, the number of seats on the plane, the speed of the plane, and also the type of engine the plane uses. So these are the kind of data also you can get from your planes table. So all this data, now the planes table now in this situation is related to this flight table by tail number. So once you get the information about a plane, then you use this tail number column in the flight table, and you also link it to the planes table to get information about a particular plane. So most of the time we usually use relational database because we don't have a table with a very long number of columns. So maybe to try and make things easy for us. So when we just store the details of the airport in another table, store the details of the planes in another table, store the details of the airlines in another table. The last table we also have is the weather. We have the weather table. So this is the weather table also. So we also have the weather. This is the weather of that particular airport, that particular year, 2013. So you can see we have for various, as you're looking at it, we have EWR. This is for EWR. So this is the situation of the weather at that particular time the flight took off for each particular airport. So if you want to know about the situation of the weather of a particular airport, we are going to be using the weather table. So we are going to be linking it with the airport codes. As you are seeing, it's EWR, EWR, EWR. We also have for other airport codes when you go down. So these are the 5 data we are going to be dealing with: flights, weather, airports, planes, and airlines. So these are the 5 data we are going to be dealing with. In this lecture, I'm going to be talking about grouping and summarizing. So how can you group values in a variable in your data and also summarize it? If you can look at our data now, we can see we are having, for example, year, month, and day. Now we know we have 12 months in a year. And now we want to find the particular details for each particular month. For each flight now that took off in a particular month, we have the details already. Now, what if I'm interested in getting the average departure time of a particular month? Or let me say the average departure delay in a particular month. I want to know in which particular month our flights delayed the most. Then this is where grouping and summarizing comes, because I have my data now. I cannot just get the average departure delay with this data. I first have to group this data by month and now summarize the average departure delay. This will now let me know that, okay, in this particular month, a lot of flights, the flights were delayed for a higher amount of minutes. I will now know that, okay, flight was delayed most in this particular month, using this grouping and summarizing. So how do we do that now using the dplyr? So first of all, I'm going to say flights. I'm going to type flight, which is my data. Then I'll now pass this to the group by function. So it is this group by function that allows you to group the values in your variables. So first of all, I'm going to group it by months. So I'm going to group this data by months. I'm going to say months. When I group it by months, what do I have when I run it? I have nothing. That is because the group by function needs to work also with another function of the dplyr. Most of the time, group by functions don't work alone. They usually work with other functions. And the function that group by usually goes is async with is the summarize function. So the group by works very well with the summarize function. You can also use it with other functions, but the group by function can't stand alone. So I'm going to pass it to the summarize. It is very easy to understand and remember. As you can see, the functions are easy because group by, you know, you are grouping, summarize, you know, you are summarizing. Now, what do you want to summarize? I want to summarize the average departure delay. So I'm now going to create a new column called average departure delay. So this is the new column I'm creating. Then what is this new column I'm creating? I'm going to say the mean depth delay, which is our column for departure delay. Then I'm now going to say na.rm is equals to true, because inside this our data we have some values that are missing and we don't want them appearing. So I'm going to say na.rm is equals to true. This is going to remove missing values for me. So when I now run this, you can see I now have something like this. So you can see that average departure delay, you can see that on the month of January, which is first, we are having average departure delay of about 10 minutes. When you look at that of February, also about 10.8 means approximately 11 minutes. When you look at that of March, we have 30 minutes. But we now come to months such as July, we are having 21 minutes average departure delay. So with this now, you can now know that, okay, on the month of July, the average departure delay was very high. This can be to various reasons. I can see also on the month of June, we have also a very high departure delay of 20. So this is going to let us know that, okay, during the month of January, we have average departure of 10 minutes, which is low compared to that of June and July, which are having average departure of 20 minutes and 24 minutes. Let's check for the holiday season such as December. We have 16 minutes average departure delay of 16 minutes, while the lowest was recorded in November, average departure delay of 5 minutes. So this is what the group by function and the summarize function allows you to do. So let's check for the average departure and average arrival delay. So if you can see, we did for average departure delay. So now I'm going to check for average. I'm going to create a new column, average arrival delay. This goes to the mean, then arrival delay, the column arrival delay. We're going to take the mean of the column arrival delay, then we're going to remove missing values. So we're supposed to be expecting two columns here. So you can see our data has been grouped by months. We have the average departure delay and we have the average arrival delay. So in January, the average departure delay was high, while the average arrival delay was also low. But for that of June and July, the average departure and arrival delay still remain the highest. As you can see it, average departure delay was high, and average arrival delay was also high compared to other months. So this is an interesting insight which you can get from our data, knowing that, okay, in this particular month that we have a lot of flight delay. Another thing also we can do with the group by, we can use it to find the average carrier delay. So we want to know, for now we just did particular, we want to now know which particular plane carrier delays most. So this is very interesting for anyone that wants to book a flight to know that, okay, I'm not going to use this particular plane carrier. They usually delay flights. So what am I going to do? I'm going to say flights. I'm going to pass these flights to the group by function. Then I will now say carrier. I'm going to be grouping by the carrier. So that is why I'm putting the carrier in the group by function. And I will now pass it to summarize. I'm now going to say average. I'm going to say average carrier delay. Or let me just shorten it. I'm going to say average carrier delay. Now I'm now going to say the mean of departure delay. So I'm going to find carrier with the carriers that are having high average departure delay and also average arrival delay. So mean of departure delay na.rm is equals to true. Then I also go to get, let me put this as average carrier departure delay. Then I also create a new column, average carrier arrival delay, which is going to be equal to the mean, then arrival delay, then na.rm is going to be set to true. So when I run this now, I'm going to be having two columns, as you can see with my carrier. So you can see carrier 9E, we have 16 carriers as you are looking at from the table. Carrier 9E have an average departure delay of 16, approximately 17 minutes. Then their average arrival delay is approximately 7.4 minutes. When you also go to that of AA, you can see carrier A is having approximately 9 minutes. They have a very low arrival delay. Now, when you now look at this now, you can now know the kind of flight you want to book, especially as someone wants to leave New York. You can now use this data to know that, okay, I want to book a flight, but I now notice that out of all these carriers, I'm only noticing that carrier US have a very low average departure delay and a very low average carrier delay when compared to other flights. And I will now want to also book a flight in carrier F9 because carrier F9 is having a very high departure delay of 20 minutes and a very high arrival delay of also 21 minutes. So with this, I can know that, okay, I'm interested in carriers like AA, AS, and also US. So I'm interested in this kind of carriers. So now with this, I can know that these are carriers I'm interested in. Okay, now you can see now we only know the carrier code, but don't know the carrier name. Then how do you do this? Then wait for me. When we go to the lecture where I'm going to talk about mutating joins and filtering joins, then that is where you're going to know, okay, you can know the details of this particular carrier. So for that, save this as a data. We're going to be needing it in the lecture of mutating joins. So I'm going to save this as a data. I'm going to call it carrier delay. So I'm going to call it carrier delay. I'm going to call this. I'm also going to save this as a data. That is for each month. I'm going to call it month delay. I'm also going to save this as a data. I'm going to call it month delay. So if you look at the data we created in the previous lecture, which is carrier delay, so you can see that we are already having data of the average departure and also average arrival delay for each particular carrier. But now you as an individual, you are interested in knowing the carrier that is actually the carrier that have the lowest departure delay, because you don't want your time to be wasted. So now we're having 16 carriers. What if in a situation where you're having like almost 50 carriers? So that means you have to be looking through all the data to find the carrier that actually have the lowest departure delay. So this is where the arrange comes from. The arrange function allows you to arrange your data by the values in the variables. So now you can either arrange your data in ascending order or descending order, depending on what you want from the data. In this situation, as an individual, you want to know the minimum average departure delay for a particular carrier. That means you're going to be arranging your data in ascending order from the lowest carrier departure delay to the highest carrier departure delay. So this is where the arrange function comes. So I'm going to pass this carrier delay. I'm going to pass it to arrange. The arrange is a very simple function. I'm going to say arrange. By default, the arrange is going to arrange your data in ascending order. So if you want it in descending order, you're going to use descend. But in this situation, we want it in ascending order. So I'm just going to say, what is the name of our column? Average carrier departure delay. The departure delay starts from the lowest to the highest. So it's going in ascending order. So which is US, then we have HA, we have AS, AA. And if you now notice that carriers with a very low average departure delay also have a low average carrier. In fact, carrier HA and AS are very fast. They even arrive before their scheduled arrival time. Also, we're interested in knowing these carriers that are very fast, that have negative average arrival delay, which means they even arrive before their scheduled time. I also have a very low average departure delay when compared to other flights. Also, if now I want to arrange it in descending order, I'm going to use the descending function. Right? Descending function. I'm going to run this. So I can now know that, okay, F9 have a very high departure delay and also a very high arrival delay. So nobody wants to even book this kind of flights because they waste time. Average departure delay of almost 20 minutes and average arrival delay of almost 21 minutes. When you have something important to do in a particular city, time is going to be wasted. So people will be interested in carriers that are having low departure delay and also low arrival delay. So that is all about the arrange. It's a very simple function that allows you to arrange the values in the columns of your data sets. In this lecture, I'm going to be talking about filtering. How can you filter the cases or the values in the variables of your data? Now you can see we have 12 months as you are seeing. So let's say now you are interested in finding only the flights of the month of January, which is 1. These months are recorded numerically. So you're interested in finding details for only the flights of January. How do you now do that on your data? Then this is where the filter function comes in place. So you just have to pass your data, which is flights, you pass it to the filter function. Very simple and easy. When you pass the filter function, they are now interested in what is the name of the column you're interested in. It is stored as month. Stored as month as you are seeing it. Then you now select it. Then you now say equals to. You give the equality sign of equals to, which is a double equals to 1. So this is only going to filter for you data for the month of January. As you can see it, we're having 27,004 flights for only the month of January. What if you are now interested in, okay, I've already have the month of January, but I also want to know, let's say for example now you want to know flights that have a departure delay of 0. This is when you now use your logical operator, the AND. Then you now say depth delay is equals to 0. So you are interested in flights that have a departure delay of 0 minutes. When you now enter, you can now see we have 1,409 flights. So all of these flights have a departure delay of 0. So this is just basically filtering that we are doing here. We have filtered for the month of January. The second, we filtered for flights with departure delay of 0. Also, we also want to check for flights with arrival delay of 0. Arrival delay of 0, I also do the same thing and enter. So you can see that our data is reducing the more we're adding the filtering, because we are interested in a particular subset of this data set. So now I'm having 37 observations, or let me say 37 flights that have both departure delay of 0 and also arrival delay of 0 minutes. So this is going to let me know that, okay, these flights in this particular month have no departure delay and also arrival delay. What if now I'm interested in, for example, I want to know that, okay, for career, because earlier that time, let's check our career data. Let me see. So career data, career delay, sorry, our career delay, you can see, let's say we want to check for flight HA, flight US. So let's say now I want to check for flight US now. We want to know that, okay, which of these flights in that particular month of January is flight US also a carrier. They will now say, and carrier is equals to US. We are going to give this in quotation mark because it's a character. So I'm going to enter, control enter. So you can see for that particular month of January, only one of those flights is for US. So the origin is from LGA to CLT. This is the origin. Let's say I remove that of the carrier, and I'm interested in those that in flights that either have a departure delay of 0 or an arrival delay of 0. I'm going to remove this and put all. So this is the symbol of all. So these flights that I'm going to be filtering from, they either have a departure delay of 0 or an arrival delay of 0. So when I control enter, I run it. So I'm going to be having flights with either the departure delay of 0 or an arrival delay of 0. So the previous filter I did, it was showing me for only flights with arrival and departure delay of 0 minutes. But now I'm filtering for flights that either have a departure delay of 0 or an arrival delay of 0. This is how you can perform filtering. You can also perform complex filtering. You just have to know how you can use your logical operators, such as the equals to, the and, the or. These are the kind of operators you are going to be using in your filtering. So I can also do for greater than or equals to. I can use greater than equals to. Let's say I want to know flights that are very fast in the month of January. So flights that are fast in the month of January in both arrival and departure. So I'm going to, so you can see we have 11,491 flights that are very fast, having negative departure and arrival delay, which means these flights actually departed before time and also arrived before scheduled time. So this is how you can perform a filtering on your data set using the dplyr function filter. Another interesting function I'm going to be talking about is select function. So you can see now this is the columns we're having in our flight data. Now let's say, for example, okay, you are only interested in the carrier, you're only interested in the carrier column, the departure delay, and also the arrival delay. So these are just 3 columns you are interested in. You just need to extract those 3 variables from this particular data. How do you now do that? This is where you now use the select function. If you now notice now, each of these particular variables have an index number attached to them, which is their position in this table. For the year variable, we have the index number of 1. You can see column 1 telling us also kind of variable numeric. For the month also column 2, column 3, 4, 5, 6, 7, 8, and so on. For departure time, we have column 4, while departure delay is column 6. So we know that the departure delay index number is column 6. Also, when you check that of the arrival delay, column 9, or for the carrier, we also have column 10. So we are going to be using all this when you want to select the variables. So first of all, you have to know that the select function, you can select by their particular name. Let's use flights, then pass it to the select function. So you can select by their particular name, which is, for example, we're interested in departure delay. I can say departure delay, then arrival delay, then carrier. So when I run this, I get only 3 columns from my data. I get the departure delay, the arrival delay, and also the carrier. So this allows me to take only the interested columns I am. So let's say, for example, the columns are looking too many for you to work with. You can just pick the columns you are interested in and start working with it. So this, for example, we have already taken or let's say we already selected the departure delay, the arrival delay, and also the carrier. I also select it by the column numbers. I already called the, for example, now when we check, we say the departure delay have a column number of 6, the arrival delay have a column number of 9, the carrier have a column number of 10. So I can select them by their column number. I'm going to use the combine function, the concatenate, to create it. I create a vector. I'm now going to select 6, 8, and 10. Okay, sorry, scheduled arrival time, I think it should be 9. Okay, so this is the 6, 9, and 10. So these are the index number of those particular columns, 6, 9, and 10. I've already selected these columns by the departure by their index number 6, 9, and 10. So it's not necessarily you use names, column names to select the variables. You can also use their index number to select them. You can also use operators such as the column. For example, I want to select the column from the index number 6 to 10. So I can just say 6 and use my column. I can select a range 6 to 10. So I'm going to get column from column with index number 6 to column 10, that's what I'm going to get. So you can see it. I can also say I need only the columns from departure delay to carrier. So it's going to give me all the columns between, including departure delay and also carrier. So all the columns between these is going to give me that. So this is another operator you can also use to select variables in your data. The next thing I'm going to be talking about now are selection helpers. So selection helpers are functions that also allows you to select columns of variables from your data set. The first selection helper I'm going to be talking about is start with. So the start with allows you to select a variable by a particular case that you're going to give. Let's say you want to select a variable that's starting with DEP, that is depth. Since some variables are not stored as departure, we can use departure, but we know that any variable that starts with deep, then that column or that variable is related to departure. I'm now going to say DEP starts with depth. So it's going to bring me only columns that start with depth, which we have 2 columns, departure time and departure delay. What if now I want to ask for columns that end with delay? Because I'm interested in knowing the flights that have been delayed, then I can now use ends with. Ends with the selection helper ends with. I'll now put delay. So this is going to select columns that ends with delay. So with this start with and ends with, you can select by particular case that you're going to give. So it is going to select, for example, a column that is standing with a particular keyword that you are interested in. Then you can use this start with and ends with to select those variables. We also have contents. You can use contents. So this allows you to select variables that contains a particular keyword. Let's say, for example, that contains car. So we only have one variable in our data set that contains car. Let's say that out of variable that contains DEL. So we have 2 variables that contains DEL, that is departure delay and also arrival delay. So the select function allows you to select variables from just like the way the filter function allows you to filter rows, or let me just put it, also select rows from your data. The select function instead allows you to select columns of variables from your data. In a situation where you don't want some particular variables to show, you don't want hour, minute, time, hour, we don't want these particular 3 columns to show. So how do we do it? You can see that they're having column number ID of 17, 18, and 19. So we can go back and use our select function. They will now say negative, then create a vector, go 17, 18, and 19. So this negative means it should remove these particular columns from the data set. So when you check it now, you're going to see that we don't have those particular columns. I can also use their names. I can use not in brackets. The column name, particular column name is hour, up to, then time hour. So if I'm not interested in these particular columns, it also gives me the same thing as we are seeing it. It's going to remove those particular columns from me. So the not operator also allows you to remove a particular columns from your data, while the negative on a vector also removes the particular index number from your data. If you look at this flight's data now, you can see that we have the air time, the number of minutes which a plane spends on air. Then we also have distance, which is the distance traveled by that particular plane. So this distance was actually saved or stored as miles. It was recorded as miles, while the air time was recorded in minutes. So now we don't have a column called speed. You want to know the speed of that particular plane. What is the speed of that particular plane? And which speed was that plane traveling? Then we have to calculate the distance. If we are to divide this distance by the air time, we're going to be having distance in mile per minute. But once we have distance in mile per hour, so after divide, we have to convert this air time to hour. then we can now divide the distance by the airtime, then we now get our speed in miles per hour. So this will let us know that, okay, we have the fastest plane, we have the slowest plane. This is where the mutate function now comes. The mutate function is a function in the dplyr package that allows you to create new variables in your data set. So first of all, we are not only creating a new variable, we are dividing this distance by airtime to get that particular new variable. So the first thing we are going to be doing, we are going to pass our flights table, pass it to the mutate function. Then we are now going to define our new variable, which is speed. So what is that particular speed? It is distance divided by the airtime. But our airtime was stored as minutes, and we want it in hours. So we're going to be dividing airtime by 60, and we're going to be putting it in a bracket. So airtime by 60 is going to be in brackets, so distance is going to be divided by airtime all over 60. So we're going to close the mutate function bracket, and when we run this, but we're interested in showing the speed. Okay, let's say we're interested in showing the carrier and the speed. Then this is where we're now going to use our select function. Select carrier, then speed. So now we want to know the average speed of a particular carrier. So we want to know the fastest carrier, the carrier with the highest average speed. So I'm going to pass this to group by. So it is going to group. Can you see the way we are linking these functions that I've already treated in previous lectures? So this is how we can link this function to extract reasonable and useful insights from your data. So I'm going to group by carrier, and I'm going to summarize, create a new column called average speed, because after summarizing, it's going to group my carrier into the carriers that I have. As you can see, we have 336,176 flights, but it's going to group it by the particular carrier I have. We are now going to know the carrier with the highest average speed. So average speed is now going to be equals to mean of speed. And I say na.rm is equals to true for cases where you have missing values. When we run this, we now have this. Then we now use our arrange to know the fastest. So we're going to say arrange to know the fastest carrier. It's going to be in descending order of average speed. So now we all know that carrier HA have the highest average speed of 480.36 of carrier VX. So let's now check the order. The end of the day, we also have carrier YV have the lowest average speed. So this allows us to know, okay, this is our fastest airline carrier, and this is our, let's say, lowest airline carrier. Now, if we now want to know this particular carrier, then we will now also link it to our other tables. All these are going to come in the mutating joins and filtering joins. So because we are going to be needing this variable in other lectures of this particular section, I'm going to save it as, let me just create a new variable. I'm going to call it carrier speed. So I'm going to save it as carrier speed, as a new variable, carrier speed on new data. So anytime we run this variable, we are going to know that this is our data that is showing us carrier speed. So also when creating variables, as you can see that this created carrier speed for us. So let me just copy these flights. This is what we are using, flights. So you can see that this created a new variable for us called speed. Now, what if we are only interested in the speed and we don't want to see other variables from that data? Then I'm now going to remove this mutate and change it to the transmute function. So this transmute function is going to keep the variable you created and dispose other variables initially in the data. So by using the transmute function, I'm going to get only the column of speed. But when you use the mutate function by default, when you use the mutate function, you are going to get the variable you created and also other variables in the data. What if I'm only interested in the variables I created using the mutate function and also the variables I used to create that particular variable? So I'm interested in speed, which I created as a new variable, and I'm also interested in only distance, airtime. So I'm interested in distance, airtime, and speed. This is where I now use the argument.keep is equals to used. So it is going to keep these three variables only for me and dispose any other variables in the data. So you can see I have only airline, airtime, distance, and speed. What if I'm only interested in the variables I created only, and I don't want to have distance and airtime? That means I've already used distance and airtime to calculate speed. So I don't need these two variables again, but I also need other variables in the data. This is why I now use the keyword unused. So when you check it now, you see we are going to have speed, but we are not going to be having distance. Can you see we are not going to be having distance, and we are not going to be having airtime? So this is how you can use these keywords on your data. So when you have already created new variables, you know that okay, I've already created this new variable, but the variables I used in creating this particular new variable, I don't need it again. Then you use unused. But if you still need those variables, but you don't need other variables in the data, then you now use the keywords used. By default, when you use all, which is the default, you're going to get everything that you use, both the variable used in creating it, the variables that are also in the data, and also the initial variable you created. So when you use the keyword all, you're going to get everything all together. So this is how you can use this argument.keep in your mutate function. In this lecture, I'm going to be showing you how you can rename your variables. So you don't like the way particular, maybe you are not the one that actually created the data or recorded the data. You don't like how a particular variable was stored. For example, now, let's look for a particular variable to change. Let's see, for example, this destination now. Okay, this dst dest. So you don't like the way it was stored. You want to store it as destination, or you want to rename it as destination. How do you now do that? I'm going to use a dplyr function called rename. So you are going to pass your table flights to the rename function. Then what is the initial name of your data? It is recorded as dest, but you want the destination. You want the complete spelling destination. I'm going to say destination is equals to dest. So the new name that you're giving is going to come first, then the old name is going to come last. Then when you enter this, it's going to rename it for you from dest to destination. So you can see we have destination instead of dest. So this is how you can use the rename function to rename the variables in your data. So I've kept you in suspense for long. We're going to be talking about mutating joins and filtering joins. Filtering joins will be in the next lecture. For now, I'm going to be talking about the mutating joins. So this mutating joins allows you to join two different tables. So you have a particular table and you want to join it with another table. Maybe there's a variable in that particular table you need. Then you can join it to this your particular table using a specific variable. So now I told that we have unique keys, we have unique columns in this flights table. Like this carrier, it is having a code UA. So no two carrier can have the same code. So we can now use this particular carrier code to carry information about a particular carrier from the airlines. So we will now go and trace it to this code to know the information or the complete name of that particular airline. So this is what we're going to be doing in this particular lecture now. So we created two data. We created carrier delay, which is showing us the average carrier departure delay and also average carrier arrival delay. So it's showing us the departure, average departure and arrival delay for each particular carrier. So and we also created another table called carrier speed, which is showing us the average speed for each particular carrier. Now, if you show someone this data, is not going to know this particular carrier. So let's start with the average speed. We now want to know that, okay, I want to know this particular, or let me know the top 5 fast carrier. I want to know these particular carriers. So how do I do that? You have to link this to the airlines. You have to link this so that I can be able to get the name. So this is where we are going to be using the mutating joins. So we have 4 mutating joins. We have inner join, we have right join, we have left join, and we have full join. So I'm going to starting with the inner join. So the inner join is going to take this carrier ID in this place. So now I want to know the carriers that we have in this place. These are table carrier speed. We want to also have carrier, we want to have like the name of the carriers, and also know that, okay, this is a particular carrier, this is a particular carrier. Because if you show this data to someone, he's not going to know the particular carrier by their code. Not everyone knows the code of a carrier. So now, how do we now do this? We are now going to be linking this carrier code to this airline data. So we are really interested in this column. So you can see that these two tables are sharing the same column. So in these airlines, we're having various carriers, as you can see. While in this carrier speed, we're having, this airlines contains almost like all the carrier names. While in this carrier speed also, we're having carriers that are particular flights data. It can be possible that a particular carrier doesn't even have a flight in that particular year. So now, we're going to be taking the inner join is going to take the codes that are in this place, that is this carrier, and match it to the codes that are in that of airlines. To make it simpler, let me create another data and call it top 5. So I'm going to call it top 5 carrier speed. So I'm going to say it's equals to our carrier speed. So it's going to take, I'm going to use the function head, which is going to take the top 5 rows for me. So when I load this top 5 carrier speed, so I can say I'm having only 5 carrier. Good. So this is going to be the perfect example I'm going to use. And now I want to know these particular carriers. So it is going to take this carrier code that are here and match it with those that are in this place, excluding those that are not there. So it is not going to show me that of 9E because I don't think I have 9E there. There is no 9E. So it's only going to show me for carrier of HA, VX, AS, F9, and UA. So it will take these particular carrier codes. It's going to now check these airlines, if these carriers are there, and extract the information for me. So that's what I'm going to do now. That is what the inner join does. So I'm now going to say inner join. I'll now say X is equals to, so we call it top 5 carrier speed. And now say Y is equals to airlines. So Y is equals to airlines. Then I'm now going to say by. So this argument is very important. By what? What do you want me to join this table with? Inner join is going to be asking you, what do you want me to join this table with? Then I'm now going to give by carrier. So it's going to now match, it's going to look for the matching carrier codes in this particular airline table and get the name of that particular airline for you. So when you run this, so you can now see that we have the carrier name. We have Hawaiian Airlines, we have Virgin America, we have Alaska Airlines, we have F9 Frontier Airlines, and we have UA United Airlines. So you can see that now we already have the name of these top 5 fastest airlines. We already have their name. I can also apply this inner join to that of the carrier delay. Equals J join X is equals to carrier delay. That's the number of table. Then Y is equals to airlines. And I'll say by what? This by is very important, by their carrier code. So you can see now, I'm going to get by that. So I already have their name. So if you can see now, this carrier code is far from the carrier name. So I want them to be together so that I can be able to know specifically that, okay, this code is for this particular carrier. So I'm now going to use the pipe operator and pass it and say select. So this will allow me to rearrange it by carrier name, then average carrier departure delay, then average carrier arrival delay. So you can now see that now the name is now close to the carrier code. So the select function can also use it to arrange your columns too in your data. So you can now say now that, okay, 9 is for Endeavor Air, A is for American Airlines, AS is now for Alaska Airlines. So I also want to arrange it. I told you that I want to know those that departed early. So I'm going to say average departure delay, because this is going to give me in ascending order average carrier departure delay. There's now going to also give me top 4, or let me put it as top 5. So you can now see. So that means this airlines that depart early and also arrive early are US Airways, Hawaiian Airlines, Alaska Airlines, American Airlines, and Delta Airlines. So let's compare it with these two also. Let me just copy this. So you can see that Hawaiian Airlines among those airlines that depart early and also arrive early, and you can see it's also the top fastest airline. When you also compare to, you can see we also have Alaska Airlines in both tables. So now if we compare these two tables now, we can see that we have Hawaiian Airlines, Alaska Airlines as airlines that depart early and also arrive early, and they're also among airlines that are fast when it comes to traveling. So you can see we also have the Alaska Airlines and we have the Hawaiian Airlines. So with this, we can know that if you are someone interested in traveling, you can know that, okay, Hawaiian Airlines usually depart and arrive early, and they are also among the fastest, they have the fastest planes. So these are information which you can get from your data. So this is what inner joins allows you to do. Then we also have the right join, the left join. So this right join and left join, they are almost similar to the inner join, but just a little difference. Right join and the left join I'm going to be talking about now. As you can see that I told you that the inner join is only going to be looking for these carrier codes that are here, and it will also go back to the airlines and look for the carrier codes. So it is going to look for this particular career code that are there and pick only them, dropping any other one that are in both tables. So if, for example, now I have a career code, let's say, for example, SL. If SL is in this particular table and SL also is in this table, but is not in that table, then inner join is not going to take it. But also, if I add, for example, UA, if UA is in this particular table I created, top 5 career speed table, and I go back to the airlines table, and UA is not there, then inner join is going to drop that UA column. So which means in my new table, I'm not going to be having UA. So that's what the inner join does. So it's going to only pick the observations that are in both tables. This of HA and the H, this HA must be in this table, and the HA must be in this airlines table. If this HA is not in both tables, then it's going to drop it. But if the HA is in both tables, it's going to pick it. If VX also the same thing is not in both tables, if VX is in top 5 career speed table, but it is not in airlines table, then the inner join is going to drop it. If VX is not in the top 5 career speed table, but it is in LI table, the inner join is going to drop it. So for inner join to be able to take observations, the code that you are using or the key that you are using must appear in both tables. Now, what of the right join? Then the right join, I told that you take this variable as the join functions takes your first table as the X, and they take your second table as the Y. So for the right join now, if we are having, in this case, we are having 5 career codes, HA, VX, AS, F9, and UA. For the right join, if these observations UA doesn't have a value in this place, for example, UA is not there, it's going to return UA as a missing value. So for the right join, it's going to return all the codes that are initially in your first table. That is what the right join does. While for the left join, it is going to return all the codes that in airlines while excluding those that VX. Better understanding, I'm going to be using a pictorial representation. So this you are looking at is the representation of an inner join, what an inner join does. So this is our first table, this is table 1, and this is our second table, this is table 2. So you can see that we have observations X1, we call this the key. So this is the key in which the table are joined by. So as you are looking at, I'm going to use a pictorial representation to explain the inner join to you. So this is the example of an inner join. This is table 1, which is your X value, and this is table 2, which is your Y table. So this is your X table and this is your Y table. So now, if you look at it, they are having ID of 1, 2, and 3. That is table X, or your first table, and this is your Y table having ID of 1, 2, and 4. So what an inner join does is going to look for the matching ID. So that argument by inner join is going to be looking for a matching ID. So if it sees 1, it's going to link it to this and join this table with that of X. Then if it sees 2, it's going to look for ID 2 in this second table and join it together. But when it sees 3, it's going to look for 3. If it doesn't see 3, it's going to drop. I'm going to be seeing 3 in the new generated table. Also, it's going to look for 4 too, also, which is from the Y, and look for 4 at the X. If it doesn't see the ID of 4, is going to drop it. For the inner join to give you a new generated table, it's only going to give you observations which are in both, that have ID or key that is in both first table and also the second table. So observations that have ID that is in both in the table X and also in table Y. That is why you are seeing we're having observations 1 and 2 in this scenario. So this is for the inner join. So the next pictorial representation that I'm looking at is that of the left, the right, and the full. So they're also part of the mutating joins. So if you can see that of the left, so it is going to join these two tables by the left. So we have table X, which is our X table, and this is our Y table. This is the first table and this is the second table. So it is going to join these two tables by the left. So unlike the inner join, which looks for only observations that are in both tables and return it for you, this one that I'm looking at, when it joins by the left, it's going to only take the observations that are here. Even if this observation is in this place, observation 3, it is not in the right table. So it is going to include observation 3, but record the value as not assigned, as a missing value. So when we say we are using a left join, we are only returning all the IDs that are in that left table or that are in that first table. Any ID that is in the second table is going to be dropped. And when an ID doesn't have an observation in this second table that you are looking at, then that ID is going to be recorded, the value of that ID is going to be recorded as a missing value. Now, from this left join, you can also understand right join. This is going to join by the right. So you can see we have 1, 2, and 3, and we have 1, 2, and 4. So observation 4 is not in the first table, that is our X table. But when you are using the right join, it's still going to return it. But instead of putting the value, because the value is not in this table, it's going to return it as not assigned. So this is for the right join. So once you understand the left join, you can understand the right join. So they are both complementary. So the right join is going to be joining by the right. So it's going to return all the IDs that are in the right table. So even if that ID is in that particular table, then the right join is going to record the value as not assigned. While the full join in this situation is going to join all the IDs. So whether an ID is in the right table or is in the left table, it is going to return those ID. And if those ID doesn't have values in both of those tables, then they're going to be returned as not assigned. So I've already explained all the joins for you now, but the most common join you are going to be using is usually the inner join, because the inner join is what is going to only take the observations that are in this join and the observations that are in that other join for you. So they both almost work basically the same way. So you just provide your X value. So let me put it more neatly. You can see it. This is it. You first provide your X value, your first table, then your airlines, your second table, then what are you joining it with by? You are joining it by carrier. So this is going to allow you to see that particular carrier name. So it's going to only look for the carriers that are in carrier codes that are in X and carrier codes that are in Y and return the carrier name for you. So now let me show you what a left join is going to do. I'm going to be using this to show you the example of how a left join operates. So this is our Y and this is our joining key, which is carrier. So now I'm going to be using a left join. So in this case, the left join is going to work similar to the inner join. That is because, as you can see, I told you that the left join is only going to check for the carrier codes that are in this particular table, which is that's your particular table. First table is going to check for these carrier codes and return the values in the airlines from the airlines tables. But if I use a right join, what do I have? So let me use a right join. So can you see that I'm having missing values now? Exactly what I explained earlier on. So whether those is going to only check for carrier codes that are in your right table. So it's only checking for, it's going to return all the carriers that are in airlines. So when it returns all the carriers that are in airlines, then if you now check this particular table, some carriers are not here. So it's now going to return the values, their average speed values as missing value. But it's going to return all their names. So this is how the right join also works. And also when I now use the full join, it's going to also give me everything, and also carriers that are not in that first table is going to return it as not assigned. Please, you can watch this video over and over again. It can look confusing, but it's very easy to understand. Last types of joins I'm going to be talking about are called the filtering joins. So this join that you're looking at here is called a semi-join. So what its filtering joins does is that they filter observations out of a data. So if you look at those other joins we treated, the mutating joins, they join two tables together. But in this scenario, it's going to filter out those observations. So now, if you look at it, we have two tables. We have table 1 and we have table 2. Now, we want to filter table 3 out of this table. So we want to only filter values that are in this table and values that are in this table. So any value that appears in this table should remain. But any observations that doesn't appear in this particular table and appears in this table then should go out. So that is where we use the semi-join. It's similar to the inner join, but the inner join joins the values, the variables together. So we're going to be having two columns in this place, one for x1, x2, and so y1, y2. But the filtering joins is only going to filter them out. So if this values is in this place, 4, and 3 is also in this particular table, the filtering join is now going to remove these 2 and only keep us with x1, 1, and x2, 2. So that is why you're seeing we're having this table. So the filtering join filters out observations that are not in the both tables. So 3 and 4 are not in both tables. Assuming 3 was in this table, then we have 3 here. Assuming 4 was in this table, then we have 4 here. Assuming both 3 and 4 were in both tables, then we're going to have both of them here, 1, 2, 3, and 4. So for you to be able to appear in the filter, then it must appear in both tables. In this case scenario, 3 and 4 are not appearing in both tables. So when you use the filtering join, semi-join, they are not going to appear in the filtering results. So that is how you use a semi-join. So the next one that we have is an anti-join. So what an anti-join does is that an anti-join is the opposite of a semi-join. So just take it that any value that appears in both of the tables, then the filtering is going to drop it. So if you use anti-join, it's only going to take the values that appear in the first table but doesn't appear in the second table. But if this particular value now, let's say for example we have 4 in this table and we also have 4 here, then an anti-join is going to drop it. So an anti-join is only interested in any observations of values that appear in this table, that is the X table, and doesn't appear in the Y table. So that is what an anti-join is interested in. So it is the opposite of a semi-join. So an anti-join is only interested in this X3 tree because it doesn't appear in this table. Assuming this S3 tree appeared here, an anti-join will not take it. An anti-join is not concerned with any observation that is in this place, but is not in this place. So it's only concerned with observation that is in here, but is not in this place. So that is why we're having 3 as the result. So this is how an anti-join works. So now practically I'm going to be showing you now how a semi-join and an anti-join works. Now let's take this as our first table, table X, and this as our second table, carrier speed table Y. So now what we want to do now, we are going to be using filtering joins. Okay, now let me just use these airlines. So now what I'm going to use with the filtering join is that this is our table X as you are looking at it, and this is our table Y. So now what the semi-join now wants it to do is that it's going to be checking for only values that are here and values of carrier. That's the carrier code that is in here and the carrier codes that is in this place without joining the name. So in this situation, it's like we are not interested in the name. So it's only interested in just checking the two. So it's going to what we are going to do is use a semi-join to what check the carrier codes that are here and also the carrier codes that are in this place without what joining the name. We are going to see what is going to how it is going to work now. So I'm going to say semi-join X is equals to, where we have top 5 carrier speed, then we have Y is equals to airlines, then we have by, which is equals to carrier. So you can see that we don't have the name of the carrier. We only have the carrier code and the average speed, and we also have our carrier here. So what if I use an anti-join now? I'm going to see what an anti-join is going to do. So I say anti-join now, airlines. I'm going to turn our X to airlines. So any airline code that is in the airlines but is not in our top 5 carrier speed, then anti-join is going to return a table for us. So you can see now it's going to return this table for us. So all these airlines that you are looking at are not in our what top 5 carrier speed. So in this situation now, when I exchange it like this, in this situation now, airlines is our table X and top 5 carrier speed is our table Y. So anti-join is going to be looking at all the codes that are here but are not in this place. So any code that is in here and is not in this place, then anti-join is going to return it for us. It's going to return a table of those codes for us. As you can see now, when you check it now, I'm not going to see HA, which is Hawaiian Airlines. Let's look for Hawaiian Airlines. So you can see that we don't have what Hawaiian Airlines. You can see that we don't have any airlines like Hawaiian Airlines. So this is what the anti-join and the semi-join does. So you can take it, just try and rewatch the video and also try and practice. You are going to get it better. So it might take a little time, but it's going to sink in. So anti-join, semi-join, these are filtering joins. While the inner join, the full join, the left join, and the right join, these are mutating joins. When we say mutating joins, they join tables from different tables together, while filtering joins only filter out. So in filtering joins, we are not joining any tables to any variables together from another table to another table. We're only interested in filtering it out. So you can see what I got from my result. It did not join any table for me. But when you are using mutating joins, then the tables are going to be joined. So the variables in those tables are going to be joined together. So you can try and rewatch the video, rewatch the video. So I also dropped some exercises, some practical exercises which you can try. I've also given the solution to these exercises which will enable you to understand how these joins operate. So most of the time I'm going to be working with the inner join and the left join. So it's going to be just some few cases now. I'm going to be using the full join and the right join. So just try and practice it, understand the inner join, understand a particular join first, then now go to the next join, understand it, then now go to the next join, try and understand it. So it's very easy. So I wish you all the best in the exercise.